In lesson 10.2, sixth graders, we are comparing numbers. Now, when you're comparing numbers, you always have to compare them in the same form. Okay? Think about comparing these digits. If you compare the 4 and the 8, you would think the 8 is bigger, right? But what do you have to look at? What do you have to look at if you compare these digits, 4 and 8? Which one is bigger? Which one is worth more, I should say?
The whole number.
The whole number is worth more. Why?
Because it's before the decimal.
Yeah, it's in a different place in the number. The place value always determines the value of the number. The place value. Okay? And when you're comparing numbers, you have to compare them in the same place value. You have to compare numbers in the same way. So if you have a mixed number and two numbers in decimal form, you can't compare those numbers until you put the mixed number into decimal form. So let's look at these three numbers. 4 and 83 hundredths, 4 and 85 thousandths. That's got 85, but it's 85 out of 1,000 versus 83 out of 100. So which one is more? This one's more, isn't it? Then 4 and 4/5. How do we change 4/5 to a decimal? How do we change 4/5 to a decimal? Sam? 4 divided by 5, right. 4 divided by 5. The top number always goes in the house. Okay? Then what? Can we put 5 into 4? No? Now what? Okay, Noah?
You put a 0 behind the 4, and then divide by 5, and that's all, which is 8.
Okay, but we can't change this to 40.
You just put the decimal.
We do have to put a decimal point to hold that place.
Then 4.
And then we use the 40. Yeah. 5 goes into 40. 0.8, doesn't it?
Yeah.
Okay. So this is 4 and 8 tenths. Or 4 and 80 hundredths. Or 4 and 800 what? Thousandths. Why would we put zeros here?
Compare.
What do these zeros do for us when comparing numbers? Great?
They don't change the number, but they make it so it's easier to compare with the other numbers.
Right. Right. So that we can compare numbers in the same place. Which one is the lowest? Trinity? Which one is the least?
Of those three.
Of those three numbers, yeah.
4.0.
Good. Yep. 4 and 85 thousandths, the middle one. Because it has 0 tenths, whereas the other two have 8 tenths, right? So this is the lowest. Which one is the next lowest? Merlin? Why?
Because in the hundredths place it has 0, and the one on top has 3.
Yep. So this one has 80 hundredths, whereas this one has 83 hundredths. Okay? Notice that they're all in the same form, so we can compare them. Okay? Now, you can also compare numbers that are in fraction form. For example, you might have to take fractions and put them in order. Like, well, this one, for example, -3.5 and -9 2/3. How would we compare these? Using a less than symbol, which points to the left, the greater than symbol, which points to the right, or it might be equal. How would we put this? What symbol would go in between here? Laura? The less than? So what? What would it read? How would the statement read then? You would think the absolute value is less than, isn't it? The absolute value is less, but which number, which value is less? If it said the absolute value, you would be right, but this is actually comparing these numbers. So we're not looking at the absolute value, we're looking at the actual values. And which one is less? And why? Which one is less? In other words, which one is lower on a number line? Which one's lower on a number line? Sam?
-9 2/3.
Yeah. So -3.5 is greater than -9 2/3. It's farther to the right on a number line, isn't it? Anytime the number is farther to the right, it is always has a higher value. Okay? Not a higher absolute value necessarily, but a higher value. And that's where this arrow comes from. It means that this number is to the right of this number on the number line. Okay? What if you had a bunch of fractions, like 5/8, 3/4, 1/2, and 7/8? How would we put these in order? What would we have to do to put these in order or compare them? You might convert them all to decimals, which we could do, right? We know that this is 0.75. This is what? 0.5. But you might be able to compare them in a different way. What else could you do to compare these? Sam? Find a common denominator. Right. Put them in the same form. What number is a common multiple of all of these? Make sure you're copying down these examples, okay? Don't just sit there and play with your pencils and look at each other. You might want to open your book and notebook. There we go, now we're getting on track. What is a common multiple of these? Caleb? 8. So 3/4 is equal to what? 6/8. Yep. And 1/2 is equal to 4/8. So now we can compare them because they're in the same form. They're all in 8s. Okay? When you have them all in the same form, then it's easy to put them in order. All right? Any questions on that? So we talked about on a number line, the negative numbers are worth less. And the higher the negative number, the less it's worth. Or the further to the right it is on the number line, the higher its value. Then you have to put numbers in the same form when you're comparing them. And you have to compare numbers with the, compare the numbers in the same decimal place, or the same place value when you're putting numbers in order also.